Hi everyone, today we'll be talking about principles of object-oriented programming part 2. So last time you should have talked about the following things. I'll show them in a second. Today we'll just extend a little bit more on the idea of the principles that you should try and follow as much as possible when you write code. So last time you were talking about inheritance, abstraction, encapsulation, and today we'll be talking about the last thing, which is polymorphism. So inheritance means that you should just inherit members from the parent class, which means that if you have also leads to the bottom one, which is abstraction. When you have similar behavior or similar data structures in between classes, that means that you can combine them in a more abstract class. So last time you should have talked about abstractions and virtual methods and so on. This is done so that you don't have to repeat code, or you shouldn't in general repeat code. So most of the principles make sure that copy pasting of code is not gonna appear, which means that it's less work for you, and it's better if someone else has to enter the project and extend it at another enemy or something like this. It will be much easier for them to do so, and also your code gets a lot more easy to read, and yeah, it's just in general good practice. Encapsulation, although with games it's not necessarily the most important things, you should hide information which should not be accessed by the user, and in this specific case with C#, you just have to put private in front of properties and methods where appropriate, meaning where other people should not be having access to those properties or methods. So yeah, all of those are all of those fine from last time? Do you have any questions? Okay, so those are just basic principles, which in C# are done one way, in other languages they will be done another way. But in general, whatever kind of application and independently of the language that you use, you should try to keep them as much as possible. Today we'll be talking about polymorphism, which is kind of weird at first, but it's also a technique that helps you reduce the amount of code. This is you can access a class through its parent interface, which is kind of weird, but I'm sure that if you see it, it will be clear and fine. All right. So what is this? It's the ability of an object to take more than one form. Or in other words, when we talk about code, the derived class can be used through its parent. So imagine a situation where you have a base class animal, and you have some derived classes like cat and dog. Okay, we'll be writing this example in a second. But what happens if you want to store all of your animals in a single collection, right? So it looks kind of weird that you would put a list of animal, and in there you have cats and dogs and so on. And even if they have similar methods, which one would be called? Would it be called the method of the animal, the method of the cat? Would the code know which method to call, and so on? So this kind of combination of similar structures, whether that will be in a method or in a list or an array or something of the sort, is very, very useful because you have to write less code, of course, and it's a lot easier to read. Okay, so derived classes can override some of the behavior of the parent class. So last time you should have mentioned that when you have an abstract class and you have derived classes from it, That means that some of the methods which are abstract means that they have to be overridden or implemented somewhere in the derived classes, which is fine. I mean, this thing is what you should have done last time. So polymorphism allows abstract operations to be defined and invoked. It also allows you to mix related types in the same collection. So this is just what I said a second ago. So you can mix different types with similar behavior in the same space, and then you can invoke functionality on them, which is also similar. So let's say that we want with the animals, let's say that we have a method for them to make a sound, okay, and we don't want to go through each cat separately and through each dog separately. What we can do is an array of cats, and then we can call the method and another one for the dogs, but we can do it a lot easier and combine them in a single structure and then go through all of them the same way. So I've already created my my project to save a bit of time. Here, let's just rename this to animal kingdom entry point. Okay. Yes, please. All right, so let's create a folder which is going to be interfaces. Not that we need to. So this example is going to be very, very simple in the sense that we will not be writing any complicated functionality or something. It's just to show how polymorphism works. So let's create a full folder real quick. I haven't worked in Visual Studio. Where is the okay? So add. I'm mostly working in JavaScript and TypeScript these days. So the interface is here, and let's make a class here. Add a class which is going to be called iAnimal, and this is going to be a very simple interface. So let's delete all of that. Of course. How did I do that? Somebody. Okay, so remove that as well. And in here, we would like to say public interface iAnimal, and again the JavaScript with the brackets. So string, or just say prop. So there's going to be a string. It's going to be called name with the get and private set. Sorry? I can't have private in the interface. That is absolutely correct. As said, my C# is a bit rusty, but what's the problem here again? The modifier public is not valid. Okay, so just say string, yeah. So just say string name, and that's gonna be fine, I guess. Okay, so if I want to, I can only have a getter and make it without a set. Yeah, that is fine as well. So I'll just remove that as well. And we want to have a single method which is going to be called string speak, which is just going to be empty. And that's going to be it for our animal. Let's now make the class from it. So let's make a class here in the main folder of the project. So this is going to be called animal, and we have to say, so this class, the idea is that it's more abstract in the sense that if you want to initialize or instantiate an object of type animal, it will be unclear what it is. Meaning that in C# specifically, we have, sorry, I have to say here using animal kingdom.interfaces, which means that we have to make just this class to be abstract. Do you know of abstract classes? Everything fine? So an abstract class is one that we cannot instantiate. So when you say animal, I want someone to make an animal. this is very unclear what kind of animal we would like. Is it a cat? Is it a dog? Is it something else? And so in order to avoid confusion, we just do not allow for this class to be instantiated because it's unclear what that would look like by making it abstract. Then we can also do methods and so on, but I'm sure that you've talked about that last time. All right, so in here I can now have my property, which is, oh yeah, of course I have to do that, animal. And hopefully if I delete that by pressing Control dot, I can do implement in the interfaces. We're not going to do into the whole expanding of the property. We just need a simple one. So we'll do prop string name. We would like to have a constructor as well, which is going to be animal, and in here we have to say string name, and inside here this dot name equals name. Okay, let me have a look if there is anything else in this method. Okay, about the speak method, we would just like to say, first of all, we would like to make it so the derived classes from it can change the way this method works. So how does that work, with what keyword? So basically we want to say, well, we are going to have this method, but we allow everyone at the bottom of the chain of classes to I don't know when I use the same word, to change this method speak, let's say this way, virtual. Okay, so if we say public virtual string speak, and then in the derived classes we just have to say override this method and do something else. Okay, so inside here we would just like to say return string dot format, and inside here something like, hi, I am an animal and my name is, and inside here we would like to say this dot name. Okay, so this is the base class, and then let's create a cat and a dog and maybe a bunny. Actually, let's create a bunny. So I wanted a private setter. This doesn't matter right now. Okay, we just create a couple of random classes very quickly to show something else in the entry point. So let's make a class which is going to be called cat. Let's delete all of that. Maybe make using animal kingdom dot interfaces. All right. Then make this class public, and if I wanna okay, so now I wanna inherit functionality and properties both from the interface and from the class. So in what order should I put them? First the class, then the interface, and the reason for that is that I can have I can inherit from multiple interfaces, but from only one class. So the class has to be first. So I have to inherit from animal and then from I animal. Was that the syntax with a comma? Hopefully it is. Am I doing something wrong? Let me just check. Okay, so this is a fair point. Let me just check. Yeah, it should be fine. This one, public class cat. What's the problem here? There is no argument that corresponds to the required parameter name. Okay, so yeah, I just need to implement the interface. Can I press Control dot here? No. All right, so this is a fair point. If I'm inheriting from animal, means that I do not have to put this in here. Which is correct, but in the same time it is good practice to list all of the interfaces that you're currently using. So let's look at an example here. So let's have a list of int, and if I press F12, so yeah, here we have that list of t implements interfaces ilist, I collection, ilist, and so on, I enumerable of t, and so on. But the thing is that each of these interfaces, so if I click on ilist, it would also implement I enumerable, which means that you just have to list all of the possible interfaces, or all of the interfaces that that we implement. So meaning that I can delete all of this and it will still be true, and it will still be fine, because for example, ilist also implements these, okay, but they're not listed only here, they're listed in the list as well. So you just list everything that you can, meaning say that we have a character and we have interfaces which are I drawable, I jumpable, I shootable, and so on. Even if you have some that are like I shotgun shootable or something, we just have to list all of them, and this straight away from where we make our class, it makes it very clear what it does. So I have to do both. All right, so let's do a property which is going to be string, and it's going to be called name, and then after that we would like to have a constructor. What is the problem? Cat.name hides inherited member animal.name. Use the new keyword if hiding was intended. Yeah, I already have a name, yeah. So yeah, here I don't have to do anything. The only thing that I have to do is, let's say, public const string sound equals now, and that's gonna be the sound that we are gonna use later on. So also we would like to have a constructor which is just gonna inherit or just reuse the base one. So we are gonna use string name, and then here base string base from name. I don't like this, so I'll just put them on the same line. Okay, after that we have a method which is going to be public string this method, which is just going to print the sound in this case. So let's do that. Return string.format the sound that it makes. Sound, yeah, why did I do that? So just sound. Okay, and let's use the other, yeah, it's been a while. So let's implement now the other method. So public string, public override string, and I should have now, yeah, speak is right here. So it will be uninteresting to just say return base dot speak, which is the speak method of the animal class. But what we want to do is use this or reuse this, and then add something else to it. So something like I am a cat. Okay, and now let's make the absolutely same class for a dog. New class. I think that was all for the cat. Turn base dot speak plus yeah, that is fine. Okay, so let's make the same class for the dog. I don't like copy pasting, but in this specific case I will. So here what we like to change is this class is now called a dog, and the sound is gonna be different, like woof. Here we have dog, which is the same. This is gonna be different, something like I don't know, woof. and then speak I am a dog. Alright, up to here everything is fine. We just created a couple of classes. We have virtual methods which we override and also reuse what we have. Okay, so a couple of things here. Let's create a cat. So let's create a cat this way. Cat, first cat equals new cat, and then call it Michel. Alright, and let's create, so yeah, let's just call a couple of the methods here. So first cat dot mer is going to be the first method. Let's call the other one dot speak. Let's see what happens very quickly. Control F5. It needs a little bit to run. Hopefully I'm not forgetting anything. Yeah, okay. So on the first line is our make sound method, and then we have hi, I'm an animal, my name is Michel, which is from the base class, and we have I am a cat, which is from the cat class. Let me just put a space here so that it looks better. Now, what do you think is going to happen if I do something weird, like animal second cat equals new cat Pesho? And what do you think is going to happen if I do the same thing but for the second cat? So second cat dot mrr. Can I access it at all? What's going to happen if I just write it? How many R's are there? 3. Okay, so I'm not allowed to call, although we create a new cat, it's still of type animal, right? But we cannot call this method because it just doesn't work. But what's going to happen, if we do the same thing but for speak? So the line below cannot happen. Control KC, yeah. Okay, so what do you think is going to happen now if we call the speak method? So we cannot call the one that's specific for the cat because we've initialized it as animal. But what's going to happen if we call the speak method? Is it going to be for the animal class or for the cat class? This is a trick question. You know, but you're waiting for everyone else. Okay, so let's discuss this. What do you think is going to happen? So is it going to behave like a cat? Because in the end, we create a cat. We do not create an animal, right? Or yeah, we create an animal, but it's still of type cat. On the other hand, we cannot use this method, right? So which one is it? So okay, so who votes for this thing calls the animal method? No one. Who votes that this thing is gonna call the cat method? Okay, so everyone know, but no one speaks. Okay, right. So yeah, it's gonna call the cat method, and the reason is precisely because of polymorphism. This means that the cat can still call the methods from the base class animal, and sort of the language or C# knows that if we have a cat and we call a method, we have to execute this specific method. The reason why we cannot call this method is because if we have another animal like animal dog, first dog, it's not gonna know whether this method is there or not, right? This is something new that cannot be called straight away for every animal, and if it could, it would be in the base class. Okay, so let's create a couple of cats first. So we have the cats. Let's create some dogs. So we have dog, first dog equals new dog, and he's gonna be called Shadow. And dog, second dog. Funny. Oh yeah, I have one. Let's pass. And all right, so let's say now that we want to make a method instead of calling for each cat or for each dog. Let's say that we want to create a method which just combines all of the animals and calls for each one of them the specified speak method. So let me just control KC, control KC. And in here maybe this one as well, control KC. So we've created 4 animals. Our second cat is created in a bit of a weird way, and we'll see if we can sort of change that, or how we can go around that, or whether that's a good practice at all. Okay, so we have a task now. We have to create a method which prints or just executes all of the speak methods for each animal that we have here. So how would we create it so that it's the easiest possible way to do it? Okay, so one way is just to create a method. So public static void I don't know, animals make sounds, whatever. Okay, so this is going to be the method, and one way is for all of the animals to do that in a single method, or we can attempt something like make a separate method for the cats and separate one for the dogs. But that's not a good idea, because we would just have to repeat the code, right? We just do the same thing. So we have to come up with a way to actually do this thing once. And let's create a list. Okay, so let's create a list of animal, and it's gonna be called animals. Equals new list animal this way, and we call animals dot push dot add. In this language, we have to say first cat, and then control C a couple of times. First cat, second cat, first dog, second dog. Okay, and as we know, here I can just say list animal, and let's call it animals. And the only thing that I have to do is for each this. So it's gonna be for each var animal in animals, and we have to say animal dot speak. Okay, so let's run this. Actually, I've not called the method. Thanks. Control Y was it? Control L was it? Yeah. Control L. Now we have to call animals, make sounds, and we call in animals. And we should expect everything to work, but it doesn't. We have to, yeah. So CW of this thing, because we just returned the strings, and I have a semicolon here. Control F5. There we go. So right now, if we try to debug this, the animal is going to be of type animal, but as soon as we call the method, it goes here and it says, well, this is a virtual method, but I'm still going to look for the specific type. So if somewhere down the line of inheritance we have if the cat has a specified method which is different from the one that I have in my base class, then I am just going to use this one. Yeah. So although this variable here is an animal and not a cat or a dog, it knows which method to call. So right now, if you notice it, something like animal dot woof is not going to work because it's just not in the base class. It's not in the animal which is of type is not in the animal which is of type animal, but here as a variable. So there is something that we can do to avoid this or to go around this. We can do something like var animal as cat, or actually let's do an if statement. So which has to be in the for each. I don't know what I did it here. So if animal is cat, then we want to do something here, but I still am not going to be able to call the MRR method here, okay, because this animal we know is still of type animal, it's not of type cat. What we can do is var animal as cat equals animal as cat, and then we can do animal as cat dot mer. Alright, and now we should expect it to work. Okay, so wherever we have a cat, we can now call this specific method. Okay, but this is a really bad practice, and I'm just gonna type it in here. Bad practice begins and here ends. Can anyone tell me why this is bad practice? Okay, so I can do this, right? So if I want to have the cats and call a specific method on it, I can do that with a casting as an as, or we can do something like this as well, and that's gonna work as well. But there is some kind of a logical problem to this whole idea in this specific method. So there is something broken in this specific method in terms of logic. Can anyone tell me what that is? Okay, so one of it is if we have another type of animal, it will be hard to change all of that. But the other thing is that this method specifically has to do one thing. Okay, so it has to make sounds for all of the animals that we have. That does not include doing something specific for the specific type of animal that we have. In this case, we wanted to do something different for the cat, maybe something different for the dog, which is bad, meaning that this method has to do precisely one thing, and that will be to print the animals. And then those kind of if statements, if we have more classes, then we have to add one of them every time, and so on, which means that these couple of lines here break the whole idea of the method, which is just do one thing, do this thing, and just not go into specific details. Another thing is because abstractions should not know about their derived classes. Okay, so this is a very, very important rule. When you have an abstract class, or in this case this is an abstract method, right, which just takes use of the polymorphism thing that we talked. So polymorphism in this case is this a specific property of the animal to know which specific method to call. But when we talk about abstractions and when you make abstract classes or methods, they should not know about their derived classes, meaning the animal should not know whether there are cats or dogs or something else. So there should be no if statements anywhere. So if this is a cat, then do something else, like initialize it differently or add different max age or something. That means that you're doing something wrong within your abstractions. Okay, so that's really the point that I wanted to make. Let me check if there is something else that I'm missing. Yeah, you can do weird things like with this. So instead of having an if statement, I can have a switch case in which I can check the type of the variable animal and then just do different initialization. So something like if I'm here and I have like a switch animal dot get type, and then I can have, so I'm not gonna write this, it's just an example. I have is a method, yeah. Can I not do that? That's weird. To string get type dot name, maybe, yeah. Okay, now I can check. So if this thing that I have, if it's a cat, so case cat, I can do no var animal as cat, the same thing. I can put it here, and I can have another case for a dog, and I can do case dog. I can make a dog again with typecasting, but you know, all these kinds of things are workarounds for something that's a problem with the idea of the method in this case. Alright, so what can this be used for? And it's very commonly used in games where let's say that you have a game with enemies coming towards you, and they're like different types and different classes. You can store them all in a list and do something with them. Say if we have enemies in an abstract way, they would all have a method which is going to be called take damage or something. Okay, so like if you want to put a bomb or something, you want to take all of these enemies, check for each one whether it's close to the bomb, and take damage from them. And instead of doing it for every specific enemy or for different lists of enemies for their specific types, so let's say that we have zombie 1, zombie 2 and 3 and so on, they are all of type enemy, and we can do the same check in a single method instead of a couple of methods, right? So this is the whole idea of polymorphism, that different types of objects can access the methods from their parent class, but also they will know which method to call. So they will call the specified method for the specific derived class, which we saw here. Okay, so that's pretty much it about polymorphism. Do you have any questions? It's just another way that you can skip writing a lot of code, because in this case here we would have to write a separate method for the cats and for the dogs, which is not going to be fine. Another thing is, I don't know if you talked about this last time about abstractions, but when you make a method, so this is like an abstract method that has to do abstract things, like it works on the animals instead of the specific classes. And also in this specific case, we take a list of animal, and the only thing that we do is for each the whole list. So is there something more abstract that I can do in this case? Have you talked about this last time? So here we're pretty much connected to the fact that we're using list, but we don't have to use list. I can do an array, and I have to do a separate method, right, for an array. Or if I want to do something like, I don't know, lists, arrays, like hash sets and stuff, then I would have to do different methods for each one of them, and they might be the same kind of thing, right? Just animals stored different way. Do I have to write separate methods for each one? Say if I have a list of animals, if I have an array of animals and maybe something else? Do I have to write 3 separate methods and they will do the same thing, or there is an easier way to do it and a better way to do it? I can use the Inumerable interface. So this is the same idea of making your classes more abstract. So in this case, I use Inumerable of animal, and what do I win here? So this is the same as with the cats and dogs and this specific method. So this specific method calls a method, calls a function of the cats and dogs, which is the same, and it's being derived from a more abstract class. This is why we can combine them into just animals, and we don't have to separate between cats and dogs. This is the same thing. So the functionality that we use is just a for each loop, which means that we do not use anything else. We do not use indexers, methods like add, push, pop, and so on. We just don't use any of that. We use a single thing, which is for each, which means that we can put the abstraction even higher up, right? Instead of using the specific list or the specific array and so on, we just use the only thing that we need in this specific method. Is that kind of clear? So the Inumerable interface, what it does is just gives you the for each loop. An enumerable set of objects means precisely that. I can just go through all of them and nothing else. It's like a set, but I cannot say give me the first element or give me the 5th element. I can just go through all of them, and this is all that it gives. And this is all that we're using now. Okay, and there is another thing that I can do here. Right now, it's not going to make too much sense, but how can I make this this method even more abstract? Making it a generic. I don't need to do that. I can make an animal. Okay, so let's say that we have animal. I'm not using it, right? So using animal kingdom dot interfaces, and now that should be fine. So yeah, this way I'm making the method even more abstract, and the idea here is let's say it's clear if we have an animal and an interface animal that they're going to be pretty much the same. But imagine that we have like a different type of animal in this case, so or different classes, like what kind of animals are there that are different types, and what are the words in English? So yeah, just imagine that we have different types of animals, and in this case I'm not going to be tied to the specific abstract class animal, but I would be tied to like all of them in the specific interface. Is that clear? Okay, so yeah, I guess that's that. So this is as much abstract as we can make it, right? There is nothing above in this specific example, and this is a good way to do it. So always think, am I connected to something that I actually don't need? So for example, if I'm using the indices of a list, then I would clearly need something like that, right? I would not be able to put the Inumerable here, but in most cases you can always make your methods even more abstract so that they will work for different circumstances. So in this case, if I make an array of animals now, this is gonna still work, right? That's not gonna be a problem. Okay, so yeah, I guess that's everything for the demo. Is everything clear? So we, in this specific lecture, or in this specific example, we combine both the polymorphism technique with the abstraction that you should always try to make as much abstract as possible. A question?
Yes, how do we solve the sound problem?
How do we solve the sound problem?
Yes, I suppose we make methods in animal.
Okay, so how do we solve the questions? How do we solve the sound problem? Well, in this case, there is no problem. What kind of problem? So what would you like to implement so that I can tell you how you should implement it?
So the cat says mir, the dog says woof.
Okay, so the cat says one thing, the dog says another thing, and I guess that you would like to make it in this specific method, right? So you have to put it either in a more abstract class, like put the either the methods, either the sound or something else. You should put it in the more abstract class. Okay, but yeah, it really depends what you want to do. But what you don't have to do or what you shouldn't do is something like this. So if you have a method which is intended to work on every single object of our list or of our collection, that means that you should not check with ifs because you break this rule up here. Okay, but if you want to have a method which calls the sounds for every animal, that means that either you have to do it separately or you have to put it in the more abstract class, or you have to store them in separate lists. Okay, so normally, depending, like if it's a game and there are like lots of enemies and stuff, what I would do is, keep all of them in a single list, but also keep track of separate lists for the separate types of enemies, so that I can, if I want to work with just one type of enemy, then I can do that. If I want to work on all of them, I can do that as well. So storing information in like different collections is not a bad thing, even if they have to repeat somehow. Did you all understand his question and his example? Sorry, my example. So yeah, that's the basic idea.
How do you make adding, removing, and consistent? You make a new class that stores
Another
every single.
question: how do you make adding, removing consistent? What do you mean
Yes, so
consistent?
you don't forget to add to both lists and not just the one. For instance, you add only to the enemies and forget
So how do we keep ourselves from forgetting to add something to both lists and then remove them from both lists and so on? Well, that's quite simple, I think. So once you have, so yeah, let's have this specific example. So let's say that we have to create a list of cats, a list of dogs. Sorry, it's just going to be list of dog and list of cat. And then we have another one which is list of animal, so that if we need to, we can work on on either on the cats, on the dogs, or on all of the animals. So what I would do is just have the list of cats initialized first, put all of the cats in there, then have the list of dogs, put all of them in there, and then after that I'll put them in the list of animal. And as soon as I destroy or remove a cat, it will be destroyed from both, right? Or not, right? Okay, so normally this, sorry, how how would I make an animal? I just
no, how you make the list of animals?
How do I make the list of animals? So here so here we already have list of cat and list of dog. And what we want to do is just copy or store an instance. Just copy, no, copy is not a good thing. Store an instance of each member of both lists in list of animal. So in list of animal, we'll have the same objects which are in the list of cat and the list of dog. They are just there as pointers. Yeah. And then if we remove one of them, they will. Sorry, if we remove them from the list of cat or dog, they'll be removed in the other class. Or you can make sure as soon as you remove it from the first list, then you will remove it from the second list as well. So they just go hand by hand. There are a couple of ways. I don't know if that's clear enough. Maybe a specific example.
Specific, because if you remove from
If I remove the cat from cats, the reference will still be here. Okay, so then I have to remove them from both, I guess. Yeah, but then you would have to know that you're storing them in two ways, and as soon as you have to remove it from one, then you have to remove it from both. Another way is every time when you have to do something with the list of animal, you just create it again, meaning like every time when you execute the method, you just create the the, the list of animal inside. Sorry, just taking the values from this list and from this list, you can put it in the animals, and then you can execute everything. This means that if you create it every time when you call the method, you would be keeping track of what's inside the list and what not, if that makes any sense. So there are different ways to go about this, but a specific example we can discuss maybe in the break if you want to. But yeah, different ways, and I think I've done that in one of the games, like the cow game, maybe in Phaser, but I don't know. Okay, so a couple of more slides, actually two more, and we're pretty much done. Okay, so we will talk about other two principles, which they don't have a demo. They're just I'm just gonna mention them so that you would know if you're doing something wrong. So cohesion, or strong cohesion, this describes how closely routines in a class method or generally in the code support a central purpose. Meaning, what I mentioned with the method that we just did. So when you have a class, it has to be for one specific thing. Okay, if you have a method, it has to do one specific thing. Okay, it's not good if you have a class or a method which creates all of the characters, then draws them, then moves them around, starts the game, and so on, or something like a method that saves files, prints files, and so on. This is bad. Okay, so everything in your code should have a single purpose, meaning if I have a variable that is meant to do a couple of things, that is bad. Okay, how are you gonna name it? How are you gonna give a name to something that has to do many things? The magic variable, right? And it does everything. So always, if you have a method or a class which does more than one thing, then you're probably doing something wrong. Okay, then maybe you have to separate it into methods, separate it into class, make it more abstract or something. And then again, this is very, very easy to spot, very, very easy to see. So if you have a problem with naming a class, or if you have a problem with naming a method, then it's that. If it does more than one thing and you have a problem with that, then you have to do something to separate the logic into different places. So in this specific case, a math class, well, you know what that is. It's gonna do math, right? It's not gonna print something or send an email or something, right? It's just gonna do math. The same thing is true for datetime. So try to keep your cohesion strong, meaning that everything in your code should have a single purpose. Okay. The next one is coupling. So coupling describes how tightly classes are connected between themselves. Okay, so there are plenty of examples, especially in game development, where people get sort of confused and they start to couple classes quite a lot. Meaning, let's say, so the easiest example that I can think of with C# is if here in animal, instead of this, I was to write CW of the same thing. Hi, I am, and so on. So this is a coupling between my class and the console, and this is something that I do not want, because if I want to transfer this class into some other application or something, or just reuse the code, and I no longer have the console as a class as such, then this is gonna break and I have to go through it over and over, right? But strings, they are everywhere. We can use them in many languages, and that's gonna be fine. So yeah, this is probably the simplest type of coupling, and I think that you've noticed that in the demos we always aim not to use the console, but rather return a string and then use it from outside. But in games this is very common, where instead of having a good structure inside your let's say that we make a game with like bunnies versus zombies or something. So if you want to make some calculations for the bunny, whether you hit a zombie or something, you would have to have an access to the zombie in the bunny class, right? Somehow. So let me write that down. So this is coupling, and should be avoided. So let's have an example here. So bunnies. Did you write this game earlier in the lectures? Yeah. So let's take the same thing. So bunnies versus zombies, and let's say bunny has to I don't know, shoot zombies, and they should take damage. Okay, so there are pretty much two ways that you can do this. So the bunny can have properties which are like a list of all zombies or something, or something like this. So imagine inside the bunny class you would have a property which is list of zombies, which doesn't make any sense. Why would we want to have it inside the class, right? It's not a part of the bunny. It's not a property of the bunny. It's something that we can just use if we need to, but it's not a part of the specific class. So do you know how to go around this? Let's say that the bunny has a method shoot.
Shoot method could take an argument which is an array of zombies.
Okay, so the shoot method should take as an argument list of zombies, and then call the method of the zombie, which is like take damage or something. The method zombie dot take damage. Still, this is not JavaScript. All right, and that's it. Now we don't have an instance of something that is not part of our class. We don't have it as an instance in the bunny class, okay? Because as an instance, it would have no job doing there, right? And this is how you normally get rid of coupling. It's not always possible, okay, to do this, and sometimes you would need to have your classes coupled because they depend on each other and so on. But if you can, decouple your classes as much as possible, meaning that there should be no straight up connections between them. And the problems are very clear. So let's say that I change the zombie class to something else, right? So there is a change that needs to be made, and let's say that I take the abstraction up, or I make, you know, different types of zombies and so on. This is gonna break because the bunny and the zombies are coupled. This is gonna break both classes. So yeah, I'm fixing the zombie class, and it breaks the bunny class, which doesn't make sense, right? It should not happen this way. So if I'm doing something with the zombies and something breaks, it should only break where we use the zombies, but not in the bunny, because it's, you know, a completely different thing. So that is the point. So coupling must be loose. There should be little or no dependency between classes. Okay, so this is very rare. Okay, so if you can make your game or application without any coupling, this means that it just doesn't happen normally, but you should try to keep it as a minimum where you can.
It's not possible because then class they'll know where to talk to each
Yeah, it's well, it's not impossible. It's not impossible, but it's really really hard to do. I can think of a couple of ways where um, you can do it, but it's only gonna make the code worse. So only couple where you feel that it's necessary, but if you can avoid it with some techniques, then do so. All right. Any questions so far? No, everything fine. Summary. So the principles are inheritance, encapsulation, abstraction, and polymorphism. Also, we talked about encapsulation and coupling. These things we talked about at the start of the lecture. Inheritance, this is all about base classes, inheriting members, constructors, and so on, everything that you can from the base class, so that you don't have to repeat code. Abstraction is kind of the other way around. So as soon as you have some common functionality or common properties or data between objects, then you should try to make it, or between classes, you should try to make them more abstract. Encapsulation, which for some weird reasons is not here, you just have to hide functionality as much as possible, and the best way to do this, in order that that you would made it right, is to just put everything private, and as soon as you get an error, change it to public or something else, right? This way you get no you'll get no error. So in this specific case, I could have made some properties internal or protected, but the idea of the demo was different. But always try to hide the information that should not go outside of the class. Another way to do this is by using getters and setters, which in C# specifically are written very very well. Sorry, they're very very easy to write. So you use that also to hide information, or only show the information that you wanted to show. Okay. Otherwise, someone can break your whole app just by changing something that they shouldn't have access to, and this has happened many times in the past. Strong cohesion and loose coupling, this is what we just talked about. This is just to avoid spaghetti code. It's just a good practice to have and something to keep in mind when you write code. And there are always ways to make your code better. It's never going to be perfect, but we can try make it as perfect as possible for what we want to do. There are compromises to be made, but if we can make very few of them, and we'll be happy, because the quality code and the good structure and abstraction are gonna pay out in the future when we have to do something else with the project. Either we have to extend it, export it, clone it, add something, change something, and so on. It's gonna be a lot easier if you follow these principles and these rules. Of course, there are a lot more, but these are the very basic ones. I'm sure that in quality code and in design patterns you will get a bit more sense of some other principles that are good. Okay, so your homework is just one problem. It's I wouldn't say that it's too complicated. You just have to write a couple of more classes. So you have a base class shape, and you have different shapes, which are circle, triangle, square, rectangle, and so on. You have to make the abstract class shape. It's gonna have two methods: calculate area and perimeter, and so on. Then you have to create triangles and circles and so on, and then just make a single method to call these two methods on all of them. So pretty much what we've done with the cats and the dogs and the animals, but you have to write some code here instead of just name and some simple methods. The picture below could be useful or not. If you can calculate there using the sides only, you should do that. Otherwise, define all necessary additional fields you may need, like angles, heights, and so on. Test your application with all possible shapes stored in a list and print their area and perimeter. Any questions here? Trapezoid in Bulgarian, I'll tell you what that is in a second. Okay, any other questions? Nope. References, and yeah, you don't have any questions, so I guess that I'll see you next time.